Hello everyone, welcome to the 12th video on Snowpro core certification series. In this video, we are going to discuss about column level and low level security within Snowflake, and then we are going to discuss about object tagging within Snowflake. This video is going to be quite an interesting video. Without further ado, let's dive deep into it. Column level security. I hope the name itself is self explanatory to a greater extent. Column level security is all about how we can add security at a column level within Snowflake. So column level security in Snowflake allows the application of masking policy to a column within a table or a view. A masking policy is the key constraint here. Using the masking policy only, we are going to achieve all the things. So by two different methods, we can achieve the column level security within Snowflake. One is the dynamic data masking, which is the native feature of Snowflake to do the masking, and the other feature is the external tokenization, which enables accounts to tokenize the data before loading it into Snowflake and detokenize the data at the query runtime. Slightly different. We are going to discuss about each and every nuances of it. Now comes the masking policy. As I already told, masking policy is the basic construct for column level security within Snowflake that is needed for both the cases. So masking policy can be well understood using this diagram. You can see policy admin here. He or she creates the masking policy. A masking policy contains a policy condition and a masking function. So policy condition is there, masking function there. Then that masking policy can be applied at the database level, table level, or column level. So as simple as it is. So masking policy is a schema level object to protect the sensitive data from unauthorized access while allowing authorized users to access the sensitive data at a query runtime. Sensitive data in Snowflake is not modified in an existing table. That is very important thing to know. When users execute a query with the masking policy, applies the masking policy condition, determine whether unauthorized users see masked, partially masked, and then tokenized data. Simple as it is, data is stored as it is in Snowflake, but while retrieving the data, that will be masked based on the masking policy. As simple as it is. It can include conditions and functions to transform the data at query runtime whose conditions are met, consist of a single data type, one or more conditions, and one or more masking functions. This is very helpful in doing the segregation of duties through the role segregation of policy administrators and object owners. The SOD is one of the major advantages of using the masking policy. Now this is the sample masking policy which I took. You can see here case when current role in PIA role, then val, meaning if the current role is PIA role, then the complete data will be given, that is the unmask. It is the partial masking is also possible using masking policy. Current role equal to support, then we will do partial amount of masking, then the complete masking is also possible. So if the role is not a PA role or a support role, whatever the other roles will see the data as masked alone. Now we are going to see a detailed example of dynamic data masking, how we can implement the dynamic data masking using the masking policy. First, let us do a simple table, user info table, which contains all these entities. Now you can see ID, name, gender, and email. So this is how it is stored. This is the original valid data which is stored within the Snowflake. Now we are creating a masking policy. Create a masking policy email mask, which will return a string value. Here what we are defining, if current role is analyst, if the role is the analyst, then we will return the value, else we will return all stars alone. That is how we are defining the masking policy. Then now we are applying the masking policy to the table. Here we are applying the masking policy to the user info table, modifying the email specific column, set the masking policy as email mask. So now what we did, we created the masking policy and we applied this masking policy to the user info table. Now comes the user. User 1 is having the role of support. He is trying to fire this query. Select star from user info from the user info table. Now if he fires this query, the output looks something like this. All the fields in the email is masked here with all stars. So all the other details will be legibly visible for him, but he cannot see the email value. Now the user 2 who is logging in using the analyst role is having the complete power. Now if you can understand the masking policy we are giving, the current role is analyst, then val. So by default the output for this specific user will have the complete email details attached to it. So now I hope you had a clear understanding of how we can implement the dynamic data masking using the masking policies. Now the masking policy can be applied to multiple objects. What if I am having the masking policy applied at various different levels? How the hierarchical precedence will work? For that we need to understand how the masking policy works within the nested object. The masking policy is applicable to the table is always executed first. The policy for the view is executed after evaluating the policy of the table. If the nested views exist, table 1, view 1, view 2 and view n, the policies are applied in the sequential order from left to right. So as simple as it is, the first execution is at the table level. Say if I created a view on top of the table, then that view level masking policy will be executed. Say if I created another view on top of that view, that will be executed at the last. So from left to right, from table to view, like that way it will go. This diagram is very easy for your understanding. Now you can see table.email. There is a policy which is attached to it. The John is querying it against the view.email here. Now you can see there is a policy which is attached at the view level. That is again simple. Now you can see this will go from bottom up. So first the policy P1 will be evaluated, then policy P2 will be evaluated, then policy P3 will be evaluated. That is how the nesting of masking policies works within Snowflake. Now we are moving on to the second category of the column level security, which is the external tokenization. This is slightly different from the dynamic data masking type, which is available native to Snowflake. External tokenization enables accounts to tokenize the data before loading it into Snowflake. This is very important thing, and detokenize the data at query runtime. We will see in detail about it. Tokenization is a process of removing the sensitive data by replacing it with the undecipherable token. External token makes use of masking policies along with external functions. We already saw to a greater detail on external functions in one of our previous videos. Typically, the external tokenization makes use of the external functions to implement this decipherable token mechanism. This picture is very, very important from the understanding perspective. Now you can see. Here, this is the Snowflake. Inside the Snowflake, we are having masking policies and we are having the external function. Now, there is the external tokenization provider, which is typically a AWS Lambda or Azure function or so. What that external provider will do, it will do the data encryption and it will ingest the tokenized data only into the Snowflake, as simple as it is. Now if you can see, Alex is the unauthorized user who is not having any access via the masking policy. If that person is trying to see the data, here he can see all this data, but this data is not the valid one. All these things are decipherable or tokenized data. But if the Morgan is the authorized user, if he fires the query, in turn what it does, it will use the external function, it will go to that external function provider and then it will do the detokenization, then the detokenization data will be provided back. Here whatever you are seeing is the valid one, valid phone numbers and valid SSN. That is how it works. So within Snowflake itself, it is storing the encrypted data only. It is not storing the decrypted or plain text data within Snowflake. All the encryptions, decryptions are happening external to it. That is the reason why it is called as the external tokenization. So there are a lot of benefits while using this. You can use preload tokenized data. It is very easy to use. Data administration and segregation of duties, data authorization and governance, and also it is very easy to do the change management if you are using the external tokenization. Now we will see similar example on how we can implement the external tokenization. There is an user info table, same thing which we saw as the previous example, but here you can see email as something different. If you remember, in the previous dynamic data masking, Smith at abc.com, John at xyz.com, Lisa at abc.com is mentioned, but here you can see all these things are in a completely tokenized way. It is stored in this way within Snowflake. That is very important thing to know. So the tokenization happens with the external function, and that data is only stored within Snowflake. Now we are creating a masking policy, similar thing. So if you are using the current role as the analyst, then it will do the de-email. De-email is the external function. It will go through that and it will generate the de-tokenized data and send it back. Else it will show the val. Val is already an tokenized data, which is the masked data. Now we are applying the masking policy using the alter table command, modify column email, set masking policy as email d token, which is already created. Now user 1 is using the role of support and trying to fire this query, select star from user info. Obviously, as you know, it will return the tokenized data which is stored in the Snowflake. Since there is a mention of val here, so this data is getting returned, but this is not the valid data, it is the tokenized data. Now if the user 2 who is using the role of the analyst, he is trying to fire the same query, select star from user info, he will get the original data. This is altogether, it goes through that process of external function call, it do the de-tokenization, do take all the de-tokenized data, then only it will be sending it back to the user. That is how this external tokenization works. There is a slighter difference between dynamic data masking and external tokenization. Please keep an attention towards it and try to understand it in a better way. As we discussed about dynamic data masking and the external tokenization, what places we can use dynamic data masking and in what places we can use external tokenization. Fortunate that Snowflake provides this in the Snowflake documentation. I just took the important information from this. As usual, as the part of the description of this video, I will be attaching the link for the Snowflake documentation as well. So in what are all the various cases where we can use the dynamic data masking and external tokenization? If you want to preserve the analytical value after de-identification, I hope you are able to understand the statement very clearly. Why? Because in the email example which we saw, there is a slighter difference only, but you are able to see the complete data there, meaning s456@abc.com. So that value of analytical value is preserved using the external tokenization, but it is not preserved using the dynamic data masking. So if you want to preload the tokenized data, then obviously the external tokenization is the right choice. If you want to preload unmasked data, then dynamic data masking is the right choice. Data sharing in Snowflake is supported by dynamic data masking only. It is not supported by external tokenization. These four are the primary characteristics which are difference between each of these, but apart from that, it is easy to use. Both are very easy to use. Data authorization and governance, both are supporting it. Data replication and account object replication is also supported by both of them. As I already mentioned, please go through this documentation, which is very important. There are some limitations as well to each of these things. Please go through that Snowflake documentation, which will provide you the list of the limitations for each of dynamic data masking and external tokenization. Now we completed the column level security within Snowflake. Now we are going to discuss about row level security within Snowflake. As you understand, column level is all about columns, row level is all about rows. How Snowflake does that? Snowflake supports row level security using row access policy. This is a different thing. This is a completely different thing. As so far we discussed about the masking policy for column level. Now we are going to discuss about row access policies to determine which rows to be returned as the part of the query result. The row access policy can be relatively simple to allow one role or view roles, or more complex to improve the mapping table approach. We are going to see what is the mapping table and all in the policy definition to determine the access to the rows in the query result. More or less same. Masking policy and row access policy are more or less same, but this is all about the row level. Row access policies can include the conditions and functions. Again, same as we discussed about masking policy. A single policy can be set to different tables and views at the same time. So same diagram. So here the only difference is the row access policy. There it is the masking policy. So policy admin can create a row access policy which contains the policy condition and row filtering logic that can be applied to a database or table at the column level. As simple as it is. Row access policies do not currently prevent rows from being inserted or prevent visible rows from being updated or deleted. So insert, update and delete is not currently supported. The row access policy can be added to a table or a view either when the object is created or after the object is created. As simple as it is. So we are having both the options available either at the creation level or we can modify it at the later point in time as well. Row access policy contains the expression that specifies the Snowflake database objects, example table or a view, and use a conditional expression functions and content functions to determine which row should be visible in each context. There is nothing more specific to it. Again, on the nesting of object, same as we discussed earlier for masking policy, same logic applies here. The first level will be table and then will be view and then will be the subsequent views and move on. There is one caveat here for row access policy. A materialized view conflict with row level security, meaning a materialized view cannot be created from a table if a row access policy is added to an underlying table. Please pay more attention to it. If an row level access policy is attached to a table, materialized view cannot be created. The other way around is also true, meaning a row access policy cannot be added to a table if a materialized view is already created on top of the table. So both the things are not valid. So materialized view conflicts with the row level security. That is the important point to remember. Now we are going to see another example on row level security, how we can implement it. For this I am just taking a sales table. Sales table is having product, spend and region. You can see fruits and vegetables, which is the sales which happened on the specific region. So for the EU region, this is the spend, and for the North America region, this is the spend. Now there is something called as the mapping table, which we already discussed. The mapping table contains some information. Here you are seeing EU sales manager role, meaning this is the role of a sales manager who is for the EU region. Similarly, the NA sales manager role is the role of the sales manager for the North America region. This information we are storing it in the mapping table. Now we are creating the row access policy. Create or replace row access policy. Security.sales policy, which returns the boolean value. Here the sales executive role equal to the sales manager regions. This is the mapping table. This is the mapping table name in which it is checking whether the current role is in this specific mapping table, and then based on that it will return the output. That is what we are defining here in the row access policy. Similar, we are applying the row access policy using the alter table command. We are applying this row access policy to the sales table using the policy which we created on the region field. Now we will see. Now the sales manager 1, who is having the EU sales manager role, he is firing this query, select star from sales against the sales table. He will see only the EU related records only. That is the important thing to know. That is what which we did. So the region based selection is happening via this mapping table. So the sales manager 1 can see only EU related records. Similarly, if a North America sales manager firing a query against this table will see only the North America related records alone. Now I hope you can clearly understand how we can implement a row level security using this row level access policies within Snowflake. As the last section, we are going to discuss about object tagging within Snowflake. Again, there is a clear mention about this in the Snowpro core study guide. So we must have to pay more attention towards object tagging. First, to understand this, what tagging is all about, it is as simple as it is. Tagging is all about an tag which we can attach to any of the objects within the Snowflake. So tags enables the data stewards to monitor sensitive data for compliance, discovery, production and resource usage use cases through either a centralized or decentralized data governance management approach. This is one of the use cases. More of the data governance and data stewardship using the tagging, it is one of the use case. A tag is the schema level object that can be assigned to another Snowflake object. Snowflake stores the tag and its string value as a key value pair. That is another thing. The tag must be unique for your schema and the tag value is always a string. So you can have a maximum of 50 unique tags that can be set to the single object. Tagging is as simple as it is. We are just attaching an tag to one specific object within Snowflake. Now, as the data stewardship is one of the example, we can use the tagging for the masking as well. That is the example which we are going to see using the tag based masking. Now, how it is possible, how this tag based masking is possible, we are going to see the series of steps. First, we will be creating a tab. We are creating a tag named accounting in the schema named governance.tags. So you are using the role of tag admin and using the schema of governance.tags, and then we are creating a tag named accounting. Second step, we can create different masking policies. Here we are creating masking policies to protect the account name and the account number columns. This is one of the masking policy which does the account name mask. Here we are seeing if the current role is account admin, then only the value, else it will return masked as the value. Similarly, here if you are seeing if the current role is account admin, then return a value, else it will return the account number as -1. These are all the masking policies which is very evident. You are already aware of this. Moving on, we are attaching the masking policy to the accounting tag. Earlier, we attached the masking policies to the table. Here, we are attaching the masking policy to this specific tag which we already created using the alter tag command, and we are setting the masking policy like account name task and then the account number mask. Simple stuff. Now, we are assigning the accounting tag to the table. Instead of directly assigning the masking policy to table, here we are assigning the accounting tag using the alter table command and then set the tag as this one. Now this comes if we fire a query using the role of account admin. If I fire select star from finance.accounting.name, it will give me the account name and account number which is very valid. Say I am using the analyst role, if I fire the query against it, it will provide me the masked value only. We already described it as masked and -1, so that is the reason why we are getting it. It's one of the example of tagging, how we can use the tagging to implement the masking with tagging instead of directly using the masking policies. With this, we come to end of this video. Before concluding this video, I would like to take you through one very interesting blog. As usual, I am going to provide the link of this blog in the description of this video. This covers the entire dynamic data masking, external tokenization, how we are doing. Everything is covered as the part of this blog. It's a very well written blog by Vikas Jain. Please take some time and go through this. If you go through this specific blog, you can understand the column level security in Snowflake to a greater extent. With this, we come to end of this video. I hope this video has been informative for you. As usual, please do write lot of comments. That is very important for me to enhance the course contents. Thank you very much for watching this video.